It's my pleasure to introduce Mr. Sandip Jadhav. Mr. Jadhav is the co-founder and CEO of CCTech. He is an alumnus of IIT Bombay and MTech in aerospace and aerodynamics. With over a decade of experience at simulationHub, he is dedicated to the mission of democratizing simulation technology, making it accessible to every individual. Since 2020, he has been a committed full-time member of Ashrae, focusing on enhancing occupant thermal comfort and indoor air quality within the HVAC community. Additionally, he is a dedicated full-time member of ISHRAE and holds accreditation for Natural Engineering Design Awards, complementing his program and technical skills. Today, Mr. Sandeep will briefly share his views about occupant thermal comfort simulations at design stage for ASHRAE 55 compliance. So, without further ado, please join me in welcoming Mr. Sandeep Jadhav.
I'm going to focus on a specific aspect of occupant thermal comfort and how you can do it at a design stage, because this is one of the area pretty much many people are unaware about. So I thought I will just focus on this special aspect. I think we are in a thick of thin of so many things in HVAC that we sometimes forget. People are the reason the building exists, and we need to definitely evaluate how the build envelope and then the HVAC system is going to affect the people, and we need to follow a scientific methodology to do that. Thankfully, there are a lot of new technologies that are available to evaluate the occupant thermal comfort. I think, as I said in our panel discussion also, one of the big problem happens in HVAC design is where we consider, thermostat is the only parameter for a thermal comfort. We, as I said, outsource our idea of what thermal comfort is to temperature, and then if you look at anything what people do in HVAC design, say, okay, I achieved my set thermostat temperature. Now I will say people are comfortable, and that's where the illiteracy start. It's like saying the taste of cake is based on the amount of baking soda. Baking soda is one of the ingredients, so temperature is one of the ingredient. There's so many other ingredient that decides what the thermal comfort will be for a person in space. So I'm borrowing some slide from my mentor Robert Bean. He's a really great ASHRAE fellow. So what are the things that happens when a person is there within a space? There are a lot of things that are affecting. There are different kind of radiations. There's a short wave radiation, there's a long wave radiation, the humidity part of it, the different temperatures that are there. So all of that matters. There is a draft that is falling on a person, what sort of clothing that person is wearing, what sort of metabolism rate, what sort of activity that he is doing. All of this actually decides whether that person is going to feel comfortable or not comfortable. Once you start to factor in this in your design, definitely you start to get a better and better in occupant thermal comfort. So another thing is, because in here we are trying to complete the projects, so we want some code, and then we say, okay, we satisfy this code, like am I comfortable? Unfortunately, that's not the case. Although I'm going to talk about the code, that no, please don't consider code as the comfort. Code is definitely a guideline. It's a directive principle which helps you to get into that direction. The another thing is, many people misunderstand and may say that, oh, I've done a heat load calculation, I have done a heat gain, heat loss, I got the thermal comfort. Please, that's not the thermal comfort. That's what is you're doing for sizing your HVAC system. That's what you start with, but that's not the end. And again, people say, okay, I put up a best system, I got a HVAC design, I put up a diffusers, I'm done, and now you should feel comfortable. It's as if it is that person responsible to feel comfortable. It is not that. So again, HVAC design itself is not a thermal comfort design. Thermal comfort design actually starts after this. So if we understand this, I think we are in a right frame to understand more about this subject. So there are so many things that that affect the person. There are temperatures, there are, as I said, metabolism rate, there are draft, there are radiant temperatures. All of this actually affect that person, and where that person goes, thermal experience also keeps on moving. So how do we do this? So there are definitely some of these parameter which plays a huge role. air temperature, the air speed, the air incident on that person, the radiant temperatures, which many times again not understood by many, how big that impact that they will have, the clothing, humidity, and the metabolism rate. So once you combine all of that, you are able to come up with a saying that okay, whether this person will feel comfortable or not. It's at the end state of mind. So a woman may not feel comfortable where male feels comfortable. Agar men and or the adult feel comfortable where kids may not feel comfortable. So it's a more nuanced subject in that way. But with a given a time, I think I'm trying to explain this importance of each of these parameters. Definitely, there are standards, and I think even if we start to follow the standard, we will start to feel a better thing. These are not mandatory. Even in US and definitely in India, there is ASHRAE 55 compliance is not mandatory. It is voluntary, and I think people in public spaces definitely should start to look at this. ASHRAE 55 gives you a good guideline about what sort of PMV value you should maintain, what sort of PPD you should maintain. There are again a lot of thermal indices that are available for someone to evaluate. But these are the most important thermal indices, and ASHRAE 55 talks about it. So it talks about the two important one. One is PMV value, where it tries to use all these four parameters and try to tell you whether you are going to feel cold, whether you are going to feel hot, slightly cold, slightly hot in that terms. And then it also comes up with a local discomfort parameter. Local discomfort parameters are again very helpful. So these are basically draft effect. It comes with a vertical temperature difference, floor temperature difference, radiant temperature asymmetry. Let me just give a small example of this. Let's say you are driving by a car, and you have a good air conditioning system. Your space temperature is 24 degrees centigrade, even 22 centigrade, and then there is a sun falling on your left arm. You'll still feel discomfortable, although space is comfortable, because now what happened is one side your body temperature and other side of body temperature, there is a considerable difference. So these are the nuance aspect of local discomfort that also makes a huge difference. Definitely there are air quality standards, and there are about IAQ and other things, but I'm just focusing more on occupant thermal comfort aspect here. Okay, so how we are trying to help here is we try to build one application for the designers. So basically, what you do is you bring up the architectural design. This is one of our applications, one of the things, but there are many others also you can use. You give an enclosure design, you provide an interior design, and you bring in the mechanical system design. You bring all of this and put into our application called autonomous HVAC CFD, which helps you to evaluate indoor air quality and thermal comfort. So it produces the set of parameters which you can actually look at in a very detailed part. So the complete field is being simulated for you for humidity, temperature, radiant temperature, draft effect, and it also does the ASHRAE 55 compliance. So ASHRAE 55 compliance, in a sense, it will tell you whether your space is comfortable, compliant or not. It will not make it things. It will analyze. It will do a validation and verification at a design stage. As you can see, the inputs are required is only the building design and the HVAC design. This can be definitely done at a early stage. Many of us work with now with a BIM model, so we have done an integration with Revit, so you can directly import your design from Revit. We also made compliance report generation simple, so you just click it and then it will generate a PDF report, which will tell you within that space how many people will feel comfortable, not comfortable. So this reduces your lot of mental load and the task of gathering this data and bringing it in a very meaningful fashion. We also have a load calculations because definitely load is one of the important part. And then we have also built one AI tool to do a very quick evaluation of comfort, because we want to do some changes, so it will quickly run this part and quickly show you some of those before you do an actual simulation. And then we bring up the some other parameters such as ADPI parameter, AEC parameter, which are helpful for your evaluating how good is your ADPI design. We do a very detailed analysis on this part, so you can use this application because it's a web-based, cloud-based application. You can even use yourself to find out whether the people are going to feel comfortable, which part of the body will they feel comfortable, and which discomfortable. So that sort of thing, you can do a comparison of different systems, because when you are doing it for a large spaces, public spaces, you always have a choices, and then you want to compare which would be better. So it is just demonstrating some of those in a simple manner. And it also find out some important parameter, like how the CO2 distribution within the space will be if you have a proper ventilation within a space, and that helps you to remove the black spots of the bad air in a space. Darshana, do you have a time to do a quick demo of this?
Sure, sir.
So I thought I will just quickly show you how easy it is. And as I said, this is an Indian technology. We are giving a lot of easy access, free access. So I will welcome you to go through the website. So it starts with what I would say, getting your design from BIM, the Revit application. It will validate your design, see if the design is appropriate for the doing a simulation. So it will verify the seating, the the ducting and the diffuser layout and every aspect of it, and then it will take this the whole input, upload to Autodesk Construction Cloud, where it is securely stored, and then from this as part we will bring it to our web application, where you can start to work on this. Here you can bring up multiple airside systems where you want to compare those for the given building design, and that helps you to choose really the right one with respect to your quality in terms of occupant thermal comfort or in terms of cost and other aspects. Here it will quickly recreate the build environment, because for simulation we also need to know weather information, because outside weather matters a lot. It will try to bring in the building layout, the orientation, and the all the detail aspect from the Revit. This helps in then creating the HVAC system that is going to be compared. We do a quick load calculation. If you already have a done load calculations anywhere from HAP or others, we can also import that Energy Plus and other results there. So this is if you don't have it, you can use it. It gives you again a detailed level of analysis in terms of component load, the building load part of it. You can download and share to your customer and other. Once you have this thing, you can create a multiple airside systems, as I said earlier. With for each airside system, you can define, you can designate whether it's a CAV system, VAV system, what sort of different underfloor systems. All those you can assign and configure for the space definitions. Once you have done this, it tries to create a scenario. Many times you want to check it for the summer condition, you want to check it for the design condition or extreme climate. Nowadays, that's a very important part that has come in. We are designing a building for future use, so people also want to use a future weather data. So we are also going to support future weather data, so that you can see how it is going to work in the increasing temperatures that are going to face by the world. Once you've done that, our AI module helps you to quickly show you thermal comfort for each of the person, whether people are going to feel comfortable, discomfortable. These are the PMV values that it start to show. It also start to generate a local discomfort information, which is helpful to identify early stage mistakes and fix them quickly. Once you got this, you go for a CFD simulation. That takes little bit more time. It would take around 3 hours to do all of this simulation. It does like 100 to 100 simulation just in 3 hours parallelly on a AWS cloud. It will run these simulations and then send you an email that all of these simulations are done. And then you start to look at the result in a more detailed fashion, where you can look at each design configuration, each scenario, and each space. So for each space, how this is going to impact it, that you can find out. As you can see, whether if it is undersized system, oversized system, you will immediately start to see the discomfort within the people. And if it is nicely designed, you will get what desired results are. It will also show you, again, as I said, local discomfort parameter that are again a lot more important for your occupants. And you can then work on this to make it compliant. We also have an indoor air quality model where it looks at whether you have enough amount of ventilation, whether you have a right system to make sure that the CO2 is getting evacuated for the given occupancy. So it does that, and it also does a very detailed level of analysis in terms of thermal distribution on a space, or a hot spots, cold spot analysis. So basically, you're not guessing in this case, because if it's a really large space, public spaces are definitely very large occupancy. You can do all of this. Although I'm showing a very large public office example, but this can be even done for a mall. And we are doing now one airport project in South America where we are able to do it for even like 500,000 square foot of space. So that's what we are doing. And then it generates a PDF report, which is you can disseminate to your colleagues, to your potential customer, and I hope that someday there is some compliance comes in. You will also able to use for that submission.